Alrighty, hello everyone. We are done with chapter 4, and now we're on to chapter 5. Chapter 5 is kind of what I call the beginning of statistics, actually. We've done a lot of introductory stuff for you, but now we're going to start digging at what this course is really about. Chapter 5 is kind of a weird chapter because it kind of does things backwards of how we're ultimately going to do it. And what I mean by that is ultimately what we're going to do in this class is we are going to take samples from a population, and we're going to look at the information about that sample and see if we can come up with some sort of conclusion about the population. In this chapter, in order to convince you later on that we can do that, we need to do what we're going to do in this chapter, which is take a known population. So we're going to already know the information about the population, and we're going to just take a bunch of samples, and we're going to show you what happens in those samples, basically. And that way we can try to convince you later on when we don't know what's going on in the population that when we take a sample, that sample actually can tell us something. It's not just guessing. So this chapter is all based solely, completely on already known populations of whatever the data we're looking for. So in this particular example, I'm just going to show you how to do a little simulation, basically, because we're going to do a lot of simulations in this class. So this section is kind of a build up to what we're ultimately going to do. So what we have here is a known population. And we know in this entire population, whatever it might be, we know how many children in each family. All right, so we have 50.5% of the families have 0 kids, 20.3 have 1, 19.1 have 2, 7.3% have 3, and 2.8% have 4. Typically, we might have one that says like 4 or more or something like that because we just kind of give up on those big ones. Clearly, there are probably bigger families, but they don't impact the problem too much, right? Because there's not too many of them. They're not going to affect what's going to happen too much. So what we're going to do right now is just basically learn how to simulate drawing people at random from this population. Okay, so the way we're going to do it for today is just show you how to use a random number table to do it. We can also use a calculator to do it. The nice thing about the random number table is it makes us all get the same answer. This way I can check to see that you know kind of what we're doing. Okay, so here's what's going to happen. So here's the basic question. We're going to randomly select 5 people from this family, okay? And I'm just going to ask you how many total children were there in those 5 families, okay? So you could set this up lots of different ways, right? However you wanted to, but we want to set it up in such a way that we're all doing the same thing. And then we're going to use a random number table. That random number table is actually on page 703 in the back of your book. I'll use it for this example also and pick these. So what we're going to do is we are going to kind of put a, oh gosh, sorry about that. Make that a little smaller. We are going to make a third column here. And this third column are the numbers that I'm going to use to represent these people. So in other words, if I had a hat, I could put 505 pieces of paper in a hat that all have the number 0 on it. I could put 203 that all have the number 1 on it. Just kind of pointing here, right? I could put 191 that have 2, 73 that have 3, 28 that have 4, and then I could just pick 5 numbers out of that hat. That'll work for sure. It's a nice little simulation. It's pretty time consuming. Probably don't want to do that. And also there's one little minor flaw in that, and that's a minor flaw of this with replacement versus out replacement type thing, which we'll talk about in this chapter. When you have a big, gigantic population, we don't really concern ourselves with that too much. But that's just something to consider. So what we're going to do instead of using those pieces of paper is we're going to give these numbers. We're going to assign them numbers. So since these decimals are 3 digits, we're going to assign every family a 3-digit number. So what we're going to do is we're going to start with 0, 0, 0. You could start with 0, 0, 1. But let's just all stay consistent and start with 0, 0, 0. So we're doing the same thing. And since I need 505 numbers in essence, remember I'm in essence trying to simulate having 50.5% of the people with 0 families. There's 1,000 of these numbers from 00 to 999. So when I'm done here, I'm going to end up with 999 down here. All 1,000 of my numbers are there. And I'm going to write them in proportion. So this from 000 to 504 are going to be families that have 0 children. I could do a random integer on my calculator. I'm going to use the chart in the book just to show you. And again, the only reason we're doing that is so we all get the same answer. But I could use a random integer and just say, hey, find me a random integer from 000 to 999. Boom, and I got it. And then it's going to tell me how many kids that family has. So the ones will be 505 to 707. I'm just adding the 203 to that number right there is the quickest way to do it. This will be 708. I'm going to add 191. I want to make sure I don't make any addition mistakes here. So 77 plus 191 is 898. This will be 899. And then 898 plus 73 is 971. And then 972 to 999. So now I have a representation for each one of these families. Just so you know, if we had the same information, but let's say this was like 0.4, 0.2, 0.2, 68, 0.2, then I would only have to use one digit, right? So I could go 0 to 4, 0 to 3, 4 to 5, 6 to 7, and 8 to 9. So just depending on what the rounding is, that's how you decide whether it's one digit, 2 digits, 3 digits, and so on. But I have to use the biggest amount of digits. In other words, I can't just go 1 to 999. I got to go 0, 0, 1 because I can't just pick a 1-digit number out of my book. I have to pick 3-digit numbers. So now what I'm going to do is I'm going to go to the book, page 703, row 42, and we're going to select 5 families, and then we're going to figure out how many kids are in each family. So make sure I get the right row, row 42. I know it's a little bit hard to read, but you got the same book. Here's row 42 right here. Okay, let me just blow it up just a little bit so you can see it better. All right, so I'm going to have to write these down on a piece of paper over on the side here at the same time. Maybe I can just do it right here above. Let me get it so you can see it. Oh gosh, sorry about that. There are all kinds of problems here. Let me just fix that. All right, so row 42. So remember, I'm picking 3 digits at a time. So I'm going to actually show you, this is the kind of work you would show in a simulation. So the first 3 digits I'm going to pick in row 42 are 331. Okay, 331 in row 42. Then I'm going to go 851. All right, I'm just writing it down. No, you can't see them. You'll see them in a second. Then we're going to go 623. Then we're going to go 241. And then we're going to go 941. So there are my 5 digits, my 5 numbers. Notice when I went through these spaces here, by the way, are just so you can visualize it a little better. Always go across, always go 3 numbers. We need to get the same answer, so this is the process. You can't make up your own process, although some processes are just as good mathematically, but you can't make them up. You all want the same answer. So now I got these 5 numbers. So notice the 331, those people have 0 kids because they're in that range 000504. 851 has 2 children. 623 has 1. 241 has 0. And 941 has 3. 2, 4. So the actual question was how many kids are in the family? There were 7. Later on, we're going to look at the average. So the average would be 7 divided by 5, right? So that's kind of the process. For doing a simulation using a random number table, and we all want to get the same answer. And see that work that I just showed there is the kind of work I would expect. What's the number? What does that number correspond to? Okay. So you're going to get to practice a couple of those tonight's homework, different amount of digits each time. This population that we just did here has a mean and standard deviation, right? There's a mean number of kids per family and a standard deviation. So, oops, let's make this a little smaller so I can fit it all on the screen. All right, so this would be land here. So we're going to compute the mean. So some new notation for you here. X bar, we've talked about. I've kind of interchanged these symbols a little bit. Now I got to stop doing that because now they have some meaning. So X bar is the mean of a sample. So if it's a sample of a population, we use X bar just to distinguish. This mu is the mean of a population. S we've been using all along for standard deviation is the standard deviation if it's a sample. And sigma is the notation we use for standard deviation of a population. This happens to be a population we have. This is the entire population here. So when I do this math, I'm going to go ahead and use the proper standard deviation. So remember, this is just, I can actually find the mean and standard deviation really quickly. I'm going to just throw my calculator up here. I'm going to move this down just a little bit. And I'm just going to go 2 less. So remember, this is just like a frequency list, right? This is the number of kids and their frequencies. Even though the frequencies are actually probabilities, it's still a frequency. Probability just got divided by the total anyway. So it's going to be just fine. So I'm going to go here to list 1, clear that out. I'm going to put in 0, 1, 2, 3, and 4. And then I'm going to go list 2. And we're going to go 0.505 and 0.203 and 0.191 and 0.073 and 0.028. And then we're going to go calculate my one variable statistics. Now remember, I'm going to do it on list 1, but list 2 are my frequencies. So even though they don't seem like frequencies, they are, because they're probabilities, which are the same thing as frequencies if you just divide them by the total population. So the calculator is going to do all that math for me. And then when I hit calculate, I get the mean and the standard deviation of the sample. What's up, guys? I'm just going to do this. Okay, cool, thanks. And notice that the standard deviation is, sample standard deviation is not there, but the population standard deviation is, which is 1.11. So the mean is 0.916 kids per family, and the standard deviation is 1.11. The sample is not there. The reason the sample is not there is, remember, the sample formula is divided, is n minus 1 in it. And in this particular case, my population is 1, right? Because we've done all that division. So that's why the calculator doesn't give you that sample standard deviation. Sometimes it will give you both if we have the actual people, and then you have to just know if it's a sample or population. This one, it's just assumed it's a population because of the way we set it up. And notice you also get minimums, quartiles, medians, and all that kind of stuff also. All righty. So that's it for 5.1. We're going to do a simulation in class next day, I think, which is on a Friday. I don't know where we are here in my calendar. Yeah, it looks like on a Friday. Just to kind of put this all together, your homework will practice this a little bit. Let me know if you have questions.